Okay, so my background for speaking about this with at least some kind of knowledge is that I was the project director for the Danish Partnership for 3D Construction Printing. It was so that the Danish government was feeling afraid that Denmark was falling behind in this area, so they asked us and the leading construction company in Denmark, NCC, to go out, travel everywhere, research the world, come back, tell the Danish construction sector what is state of the art within 3D construction printing. And as part of that, I personally visited and analyzed more than 35 different 3D construction printing projects all over the world. We're also the author of a 180 pages report from the partnership, the only report that actually exists about 3D construction printing. You can't read it, it's in Danish, it was made for the Danish construction sector. During the course of this government project, we also built 2 test printers, 1 by 1 meter that we see down here, if I can point, and another one 8 by 8 meters that we see here. And on those we tested 20 different recipes for 3D printed concrete that we found out there when we did our research. And then on the basis of that, we developed our own printer, a very big one, as you can see here, 8 by 8 by 6 meter. And with this, we actually printed this building over here, which I will come into more detail about later. So I do know a little bit about what I'm speaking about. So why is this interesting? Well, basically there are 5 reasons. There are 5 main advantages of this technology. The first is design freedom. And as we see here, this is a bot building while it's being printed. And you can actually see that there are no straight lines. There are no straight walls, because the printer doesn't care. For the printer to print a straight line or print a curve or a wave, it doesn't matter. It requires the same effort. So complexity is for free. This is good news for the architects. And then, of course, automation. And we all know that automation has hit industry the last 30 years, and it's about high time that it also hits the construction industry, because we don't see a lot of automation in construction. With automation comes the possibility of lower cost, higher productivity. If you notice, my guys here printing this building, there's one watching the laptop and one watching the printer. They're watching, they're not doing anything. 2 guys to do a building. Okay? 0 mistakes is the other one, because now it's a printer doing the building, not people. Better safety and more precision. Then faster completion time is a third advantage, and that's actually something that most construction companies are putting a lot of emphasis on, because it means that we can complete the projects much faster. Because basically with this technology we can complete the ground structure within, let's say, a week when we get better at it. Reduction of waste. When you print, you simply create the form from the bottom up. You don't take a standard component that you cut down, so there's much less waste. And then finally, the ability to use new materials, including recycled materials. You know, why don't we use recycled concrete, put that in as aggregates, and then make 3D printed concrete out of it, so that the waste that was created by a building activity is then has a second life in a new building. So these are the 5 main advantages. Sometimes when you're not so clever, you need other people to say it for you, so allow me to let Deloitte say it for me here. So what is it that this industry, what this technology is offering to the construction industry? Well, basically they say 3 things. They say it's faster, 50 to 70% faster completion. It's cheaper, 50 to 80% lower labor cost. And it's better because it means we can customize buildings, we can do intricate designs, and so on and so forth. Do I believe in this? No. This is not the truth right now. It's not. This is a baby industry. We are just a baby that has learned to crawl. We're not walking, we are definitely not running, and we are not grown up. But this is the future. That I believe in. So this will come. It's just not now. The industry is not developed enough. Let's look at where we are. You know, at the end of 2017, how many buildings were out there? We are actually talking about a very, very limited amount of buildings. 14 buildings, 6 structures, including 2 bridges in Europe, 2 houses in Europe, but there were 66 ongoing research projects, etc. How many have seen pictures of 3D printed buildings? Can I see show of hands? How many? Yeah, so roughly speaking, 40–50% of you have seen it, despite the fact we are talking about 14 buildings, right? It's not a lot. So in other words, the hype that has been generated has created a lot of interest, which is very, very good, of course, in the sense that we get attention to this new technology. What is bad is that it's left all of you with the wrong impression of where the industry is. Now let's look at a little bit about the buildings that has actually been made, and allow me the modesties to start with my own, which is Europe's first 3D printed building, which was done in Copenhagen in the harbor, and you see it here partly finished, and you see here a rendering of it, and you'll see complete pictures and a video later on. We were in a hurry. We started on the 11th of September. These guys, Nantes University, started on the 14th of September 2017. So they did the second one in Europe. Now going to Asia, and these are all by Winson, which is a Chinese company that has promoted the industry the most, created the hype. I guess a lot of you have already seen this one. Then they did a courthouse, they did a mansion, they claimed, of 1,200 square meters, they did a 6-story apartment, they did a curved house. That has not really been published a lot. And then they did this one. How many have seen this picture before? We are down to maybe 10–15%. Fantastic picture. You know, they came out and said they 3D printed this building, created a lot of hype. Oh, fantastic industry, fantastic new technology. Look at everything we can do. Unfortunately, not true, but I'll come back on that. They're not the only ones in Asia. There are other people in Asia, like these guys. Well, I forgot one thing. All of these buildings except this one, which is actually in Dubai, all of these 5 buildings that have created all the hype, they're actually standing in the parking lot of Winson. They're not in use. They're standing on the parking lot. Okay? Now, going further, there is this house also on the parking lot in up north of Beijing. And then there was this one. It's unfortunately not generated a lot of interest, but it's a very good project done by Total Custom. It's done in Manila, the Philippines, and it's a really, really nice project, as you can see. It's actually a working suite. It's part of a hotel. Nice, nice project. Then there was this one done in Russia. This one, how many have seen pictures of this one? Yeah. Are you not getting any news here in Ireland or what? I mean, you know, ABC brought the news about this building, and they brought it on the 8 o'clock news, and the Russians came out and say, we 3D printed this building in 24 hours, and it only cost $10,000. Next day, they had 3 million downloads of their video. Within 3 days, they got 5,000 emails. They gave up answering them. Part of the reason why they gave up answering them was the fact that the typical email they received was from some dumb American person saying that believed the story, said, well, you know, I have a house in the Tennessee, and I have a piece of land at the end of my garden, and you know, on Thursday I'm available, so if you can bring your printer and print me a house for $10,000 in one day, that would be nice. How do you answer that when you've come up with something that wasn't true? Anyway, and then there was this drone laboratory done here in Dubai. Dubai is particularly interesting because the Sheikh of Dubai have decided that by 2030, that's just in 12 years, 25% of all buildings in Dubai must be 3D printed. 25% in 12 years. Now, he cannot decide that completely on his own, because that's sort of the market and real estate developers, etc. But what he can decide is what the Dubai authorities are buying themselves. So he's put out another measure, another goal, that he's told all his authorities that by 2023, that's in 5 years, ladies and gentlemen, 18% of all buildings paid for by the Dubai authorities has to be 3D printed. 5 years from now. Okay. Now, let's look at the US. They're always technology leading, etc. Not in this case. So the US is not really picking up on that, on this technology, probably because of risk of lawsuits and insurance issues. Nonetheless, if we look at the last 10 and 5 years, there's been an exponential growth in the amount of projects that we have seen, and especially the last 5 years, as you can see here. But let's not kid ourselves. You know, as I said before, this is a baby industry. If we look at a normal market maturity curve, it starts with the introduction of a new technology, then it goes to growth, maturity, saturation, and then in the end, the technology is taken over by another technology. Let's think about typewriters, for instance. At a certain point, typewriters came into every home, etc. Everybody loved typewriters, and then IT came and typewriters died. That's not where we are. You know, this industry is not even here or here, it's here. It's baby industry. We are taking the first steps, significant steps, but we are here. And that means that market is small, prices are relatively high, sales are low, competition are low, and the business focus is to get awareness. You know, all these new technologies, guys that have invented these, they need to get awareness too. Wow, this technology is out here, and we can use it, and it can be doing something meaningful. Now you understand why they go out and say these crazy things, some of the others. So that's why they went out and they said they 3D printed the office of the future in Dubai, that Winston said. Unfortunately, it's not true. First of all, this is what they 3D printed, okay? So these are two shells printed lying down like that, and then put on top of each other. They're printed as components, and they're printed in China, okay? So all the interesting stuff was done manually by hand. If they had shown this picture, how much PR would they have gotten? Yeah, so that's why they showed that. Now looking at the AP's core and their 3 million times downloads, yeah, they did not 3D print that in 24 hours, and it definitely cost more than $10,000. They are basically only speaking Russian, these guys, but we have a Russian speaker as part of our employees. And so we were invited over for an event in October where they said during 3 days we're going to 3D print this building. And we said, great, you know, we're sending one of our employees over to see it. When he left after 3 days, this is how much they printed. But then in February 2017, they showed this picture in the middle of the winter, and then they said, we 3D printed this building in 24 hours. No, it took 4 months. Still, it's a good building, etc. But it was just too much saying that it was done in 24 hours. I asked Nikita, the CEO, why did you come out and say this? You know, well, it's not true, obviously. Nah, well, you know, Henrik, it could have been true. And there is actually a lot of sense in what he's saying. It could have been true if we didn't fuck up so much, sorry. And we did the same. We did the same with our building because it's bloody difficult to do something the first time, right? Think about how good you were when you drove a car first time. Does that mean the car was bad? No, it meant you were bad as drivers. Same thing here. Same thing with AP's core. So yes, it could have taken 24 hours if they hadn't run into various kind of problems that they didn't expect and various kind of things that they hadn't sort of prepared for. So in that sense, he was correct. Now, this one probably you don't know because apparently news is not coming to Ireland. CASA went out, and that made a lot of story in Dubai and the Middle East at least, and also in Europe and the US. CASA went out, showed this picture, and an American company, and they said, we are going to 3D print skyscrapers in 2022. No, ladies and gentlemen, they're not. They're bankrupt and out of business. And it was, of course, nonsense. Nonsense. The industry is nowhere near that level yet. Also, another thing, now coming a little bit back to what Deloitte said, actually, if you look at what has the 3D printed buildings projects that we've seen out there, what kind of cost have they actually looked at and focused on? And if we look at a traditional way of looking at cost for a building, we say there's 10% for the foundation slab, 35% for the raw house structure, walls, roof, and floor, 35% for the finishing surfaces, and then 20% for electricity, heating, plumbing, and so on. Now, all the projects, every single one of them, have focused on that, and only that. Now, you tell me, how can we have 80% cost saving when we're only looking at 35% of the total cost? Obviously not possible. So in other words, in order to achieve the 50 or the 80% cost saving, which is potentially is definitely possible, we need to also address all these issues here, and not only that. So these claimed savings of 40, 50, 70% are of course nonsense. And even for these 35%, the three years research that we did could not actually verify any of the promises made with respect to savings. So that led us to conclude that none of the completed 3D construction printing projects had been competitive so far. There might have been savings here and there, but overall, when all costs are calculated, the application of 3D printing has not been competitive. It's not strange. It is not strange. It is very, very difficult to do something the first time. So it would have actually been a surprise because there's still so much to be learned. But the technology has proven its potential, and it will become competitive if resources continue to be applied. So when we do project 2, 3, 4, 5, 6, 7, 8, and we get more funds, and we improve the technology, etc., we will be hugely competitive. This is a normal S-curve for technology development. I think most of you, at least the engineers here, will know it. We have the level of performance here, the level of applied effort over here, and it shows that any kind of technology develops in sort of a S, hence the name, S-curve technology. And our claim is that this is where we have seen conventional construction industry lately. There's been no productivity gains. All research is showing the last 30 years, you guys have not increased productivity. Different from industry, where you have productivity gains every year of 1 to 2%. But you have reached the end of the technology that you are applying right now. Now here comes our technology. We are not so competitive, admittedly, because we're new, it's the first time, it's the first version, and so on. But with the continued resources that are being put in, we will become competitive. This will be a better technology, and we will outcompete parts of the conventional industry. Right. See, the good thing is, it's not only crazy guys like me that are going around saying these things, you know, believing in our own technology, because 2017 actually marks the years where the conventional industry moved in. So when we look at these companies, and I think you know most of them, Peri and Doka are in-situ casting equipment companies, Skanska is a big construction company, Sika is a material company, Vinci and Bouygues are two very big French construction companies, etc., etc. All these big companies, all of them, in 2017, have invested in 3D construction printing. Do you think they do that for fun? Do you think they do it just to have something to use their money for? No. They do it because they have seen the potential too. And for me, as a technology guy, and I'm not even an engineer, I'm a business person, this is really the sign that we are onto something here, that this is really the future, because now the guys that knows about construction, because we do not, we are technology guys, that they believe in it. So, with these guys comes also funding, and with funding comes better technology. And that's what I said before. If more funding was being provided, then the technology will be developed and it will outcompete the conventional construction industry. And these guys are actually assuring exactly that. Just give you a reminder. Do you know what this is? This was my first laptop. It was back in '83. I had it before Maersk Container Company, which is the biggest company in Denmark, had a PC. So I was really proud, and I was actually the big dog, because when Maersk then finally got theirs 3 months after, they only had 1 floppy disk. I had 2 floppy disks of 128K. I think today it would be enough to write an email where it said hello, and that's it. That was the entire storage capacity of those computers, right? 30 years later, we have this, and we're all using it, and it revolutionized the way we do work as managers, as project leaders, and as normal administrative personnel, and it also changed the way we live as people. Give you another example. This is a mobile phone back from the 90s. It was a ridiculous piece of equipment. It cost 3,000 euros, it weighed 25 kilos, and it could hardly call anybody. And the people who had it, they came, you know, they walked around and felt extremely important when they came into meetings with these phones, but it was a brushless piece of tool, except for that it proved that personal communication was the future. Who was spearheading this development? Actually, at that time, there was 3 leading companies in the industry. They were all Danish. They were called names like you don't know them, Storno, Dankol, etc. Okay? These companies were then bought up by Motorola, Ericsson, and Nokia within a very short period of time. And what happened? 6 years later, ladies and gentlemen, 6 years later, we went from this crazy shit to this. And that changed our world again. 6 years. This was ridiculous. This changed our world. 6 years. And then again, our world was changed again 10 years after, because then somebody invented, and I, by the way, had the first company that took a mobile phone on the internet. But in 2007, Apple also found out how to do it, just in a little bit more user-friendly way. And our world changed again. So, just a reminder. Do you know how I think it will go with 3D construction printing? Yeah, I guess you know now. So, okay, so let's look at this first building that we did. It was made under massive media coverage because, as I said, we learned that the French would start on the 14th of September. So I told my people, I don't care, guys. We are printing on the 11th of September. And I'm inviting the media and everybody. So there's 150 people there, 3 TV channels ready to film. And the evening before, we were not printing. Luckily, the same morning, they managed, and we actually started the printing under televised start of the building. So that was nice. And we used our Bob 1 printer, so it was an 8 by 8 by 6 meter printer. It was on site, so it was done where the building was supposed to be. It was a concrete recipe with 20% recycled content, layer by layer, as you can see here, layer by layer. Each layer has a height of approximately 2 centimeters. There are 200 layers in, so 4 meters is the building at certain points. Print speed was 10 centimeters per second or 6 meters per minute. So that means for printing an entire round of the building, a layer as we call it, the printing time was 15 to 20 minutes. That means it took approximately 12 hours to print 1 meter. Now the other guys, they claim they can do a building in 24 hours. I'm showing this video and I'm saying, well, I can do it in 43 seconds. So here it comes. Right. So how was it made? Starting from the beginning, the slab, there was normal digging for making the slab, the foundation. Reinforcement was coming in as normal. And then they did a plate foundation because the foundation guys came to us and said, well, Henrik, you know, these funny looking walls that you have here, our foundation have to match that. And we don't know how to do all these curves, etc. So we said, why don't we just do a plate foundation and you use the printer to print the formworks of the top of the foundation. That was pretty clever. We didn't even think about that. He had to think about that. So that's what we did. We put up the printer and then we printed the formworks for the top part of the foundation. So what you see here is actually the last 60 centimeters of the foundation, which was made with the printer. And that's actually what we printed while the media was there. And then the foundation guy came in and he did cast out the rest of the foundation. He put in insulation, all the European requirements for separation and so on. And we had rebar going in and wires and plumbing, etc. Then when that was done, we then 3D printed the front and the back walls. And if we had no problems, it would take 50 hours. Did we have problems? Yes, multiple. Did we have problems with the 3D printer? No, not really. It was not the 3D printer that was a problem, it was materials handling. So for instance, we had hoses explode on us with concrete and things like that. And that's because we are not concrete guys, we are 3D printing guys. We put in insulation in between the walls. Of course, it's recycled insulation, so it's recycled cellulose. and then we applied roof, doors, and windows. We left some of the walls as just painted them of the original 3D printing, and some of them we smoothened. We put in a kitchen and so on. On the outside, we left, again, some of the walls as they were 3D printed, and we also applied brick slips, because bricks are extremely popular in Northern Europe, and you also have them here. And then we did smoothing of the outer wall and the finishing work, etc. And so this is basically how it looks like. You're more than welcome to come and see it. We have busloads of people coming to see this building. And let's just look at it in a little more detail. One of the things we learned that it was fine that we could do all these funny shapes and so on, and it had no cost for us. But when the roofing guys came in, we learned differently, because the roof turned out to be 5 times as expensive as a normal roof. So, you know, this technology has the ability to do curves and shapes and all kinds of things, but don't go bananas. And, you know, think about the other guys, the other trades coming in afterwards. We learned that the hard way. Now, we've had enormous interest for this technology and for the building, etc. And 3D Printhuset is a general 3D printing company. So in order not to get it too confusing, we've actually now created a separate company called COBOT, which stands for Construction Building on Demand. So it's a new sister company. All the construction activities have been put over there. We've just won the first tender. Hello, there's been an EU tender for construction printers. An EU tender, huh? That means that there are a market out there now for construction printing because people are starting to buy and they are required to do EU tenders then. And obviously we wanted a reference to the bot building because it's pretty famous. And then the good thing about the COBOT name, it almost sounds like robot, and that's basically what we do. We have launched a 2nd generation printer now, based on the 1st generation printer that we had, where we used to do the bot with, the first building. And so basically that's the only 2nd generation. Already there is showing you how much of a baby industry this is, because we're the only one who has a 2nd version of the technology, but we do have that. It's a modular system, so that means we can do any size. You want 2.5, 5, 7.5, 10, 12 meters in the length and the height and in the width. We don't care. We just put on another module. We did improve the material handling system because that was really what gave us a lot of trouble. We also improved the speed, the reliability, and quality. It's actually now the hardware is capable of printing with 1 meter per second. Think about that. 1 meter per second. Okay? 1, 2, 3, 4, 5, 6. I printed 6 meters now in 6 seconds. That's how fast. You know how much material that is? That's almost 10 tons of material per hour. Can we handle that? No, not right now. We can handle 20, 30, 40 centimeters per second, but again, the limitation is in the material handling system and in recipes, etc., etc. It's no longer the hardware that is the problem. It's all the other parts of the system. If we could have printed with 1 meter per second for the bot building, we would have printed the building in 4 hours. 4 hours, okay? That's how fast that is. The hardware is capable of doing it. We just need to figure out how we get the pumps, the hoses, and the materials also to be applied that fast. Anyway, I show a couple of examples here. This is a 4x8x3 modular, so that means it can print 10 by 20 by 6 meters in the height, so it can do a 200 square meter house in 2 stories. The price is 360,000 euros. Here's a 3 by 3 by 2, so it's a little cheaper, it's 220. The good thing is, it's for sale. So if you want to be part of this new revolution, it's maybe time to consider doing it. Thank you. I was basically just on time, right? No, precisely on time.
Perfect. Absolutely perfect. So I'd like to thank Henrik for overcoming his natural shyness to be with us here today. Listen, I know you do have to catch a flight shortly enough. You gave the example of phones, and we saw the massive transformation in a couple of decades. We saw the typewriters and the personal computers and the massive transformations. 3D printing, we're at that early baby phase. But if you were a betting man and you were putting some money on when we can see it commercialized in the mainstream, what sort of timeline would you be putting towards it?
Not more than 3. We are already next year in the spring we are a technology company. Huh? That means we don't do construction, we don't do buildings. And as I said, we are not terribly good in construction knowledge, because again, we are technology people. But we are doing a project next spring, not in Denmark, but in a big European country, together with a local contractor, where we are doing 8 buildings in one project. It's refugee housing, because as you know, all over Europe, there's a refugee housing problem. It's actually been priced 20% below the lowest cost social housing in that country. 20% below, right? So that means, from a commercial point of view, it's already proven if we can do that project in cooperation with that local contractor. So we are participating in that project. Again, we are not a construction company, but with that project, we can prove cost and we can prove speed. Because I don't think, if you look at the first building of those 8 buildings, probably the first building, it will take a couple of weeks or 3 or 4, and the second, it'll maybe take a couple of weeks, but by number 6 or 7, we'll get the hang of it. It's like driving a car. And we estimate that we will do such a building, which is a 70 square meter building, we will do that in 3 days.
I mean, you were quite pragmatic, I thought, around the issue of costs.
Yeah.
But the more the technology becomes on stream and kind of matches up with the processes, I mean, it does have capacity to take significant costs and significant man hours and workers out of the industry. Yes.
Initially, we thought that we would get all of the attention and all of the interest would be coming from the high-cost countries, and that has also come, no doubt. But we are seeing, likewise, a massive interest from places like Malaysia, India, Philippines, and so on. And the reason there is completion time. Because, we are involved with customers that are looking at doing a project with 3,000 houses at a time. Right now, they're spending 6 months. With this technology, they might be able to do it in 1 month. So their completion time comes in.
Now, I was reading a story to my 4-year-old last night, and it was The 3 Little Pigs. Mm-hmm. And the first 2 houses didn't go that well, and then eventually it all became bricks and it was all solid. I'm just thinking, if my mother, or in fact my 4-year-old were here, they just asked one question, which is, how safe is it? Is it going to blow over?
No. The Bot building in Copenhagen is really like a bunker. The compression strengths of the walls are 52 megapascal. And this compares to that, normally here you would say a maximum of 15 or 20. But if you look at bricks, etc., you're all the way down to 5 or 10. So it's a monster of a building in terms of strength.
Okay. I do want to put it out because we've just got a couple of minutes, but I know there was an awful lot of people who were nodding along and really enjoying the presentation. Is there anybody out there who wants to put up their hand? Yeah, do you want to shoot? Can we just get a microphone over before you start? And if anyone else, just put up your hand and I'll monitor as we go along.
You can ask anything. There are no stupid questions because most of you apparently have not heard about this before. So.
Thanks for the presentation, Henrik.
Thank you.
Very enlightening. Gordon O'Regan with L&M Keating. We learned a hard lesson in this country that building stuff faster doesn't always give you better quality. Mm-hmm. So how far, not being an expert in this field, how far down the line are you with, I suppose, design, compliance and insurance design life of this product and building regulations?
Well, we had to comply with the building regulations, of course, because this is a permitted building. So it's fully living up to all the EU regulations. You also saw the width. You saw that the front wall and the back wall was not touching each other because of thermal coat bridges, etc. And you saw the extent of wall insulation that was in there. Unfortunately, you know, although I said that the walls have 52 megapascal in strength, we couldn't use the walls as load bearing because the authorities told us, you know, we went to the authorities and we said, you know, we are going to 3D build or 3D print the first building in Europe in Copenhagen. And they said, wonderful. So how are you going to do it? Well, we're going to use this 3D printed concrete and this big printer. And they say, oh, you have one big problem. We don't have any pre-approved 3D printed concrete. So unless you're using a pre-approved concrete, you have to prove the load-bearing capability of these walls. I said, okay, I thought I had to soften them up a little bit, so I said, we're also using 20% recycled materials in our recipe. I said, no, that's nice, but you have one problem. We don't have any pre-approved concrete with recycled materials. So although we had already measured that the strength was 52 megapascal, we actually had to do 11 columns, and you could actually see them in the time lapse, that they were hollow columns that we printed, and we casted them out with normal pre-approved concrete. So basically, from an authority point of view, the load-bearing structure of this building is not these mega strong walls, but are the 11 columns with rebar going inside them.
Are you seeing most of the interest come from the private sector, or is it coming from governments at this point?
Well, actually, that project abroad is a government, and there's been a lot of, let's say, interest from people that are working with the government, but let's say, I would still say 70%, 80% are coming from the private sector.
And I mean, the cost of entry at this must be very high. I mean, 3D printers do not come cheap.
The cost of entry for somebody wanting to use the technology. Yeah. No, it's clear that you know, if you have to pay 300,000, pick a number, for a printer, depending on how big you want it, that's an investment. But on the other hand, if you want to have a huge front-end loader or a digging machine, you're paying the same thing. So 300,000 in your industry is not a lot of money. And this opens up the door to entire new possibilities that you haven't had before. If you buy a big front-end loader with a shovel, you don't get a lot of new possibilities. But over time, to then say it more constructively, over time I think you're correct. I think what will happen is that this will be a rental business. Because we know how it all is in the construction industry all over the world, that yes, there are some giants around, but the majority are small and mid-sized companies. And a lot of these companies, they don't want to buy or invest in equipment for 300,000, so they want to rent it. Like you are renting all other kinds of equipment that you need for a certain project. So it'll be the rental companies that will actually be renting out this equipment. It's long term. This is like in 10 years when the technology is more known and there are more versions of it out there, etc. But I think that's how it'll end up.
I think we have a question down the back.
Yeah. Do you have any comparisons of sustainability, carbon footprint, for example, between conventional build and your build?
I couldn't really hear. Can you? I can't see you. And
can you just stand up and repeat the question?
And maybe stand up because I can also see you.
Sorry.
Yeah. There you are.
Do you have any comparisons on sustainability, the carbon footprint of your build compared to a traditional build?
No, I would love to have, but you know, out of respect for that, we are a private company, not a research institute or a university. We didn't spend the money on it, but we are definitely spending less concrete than you would have with a traditional way of doing such a building. On the other hand, it's also clear that we have a challenge with respect to the material recipe, where we're using a bigger amount of cement in the recipe than what is being used when you cast normally. So there's plus and minuses. We are using far less material, but a higher share of cement in the recipe, and that's not good. So we're working together with universities and research institutions all over the world to find binders that are not cement-based so that we can bring that amount down. But generally speaking, I would say we would compare favorably.
Okay. We just have
no data.
We just have a quick question down there, and I'm conscious we're almost, he's going to miss his flight.
No, don't worry.
Thank you.
Great presentation, Henry. Bart Foley, D2 Private. Just a quick question on the technology itself. Will it have the capability of printing a newer model of itself? There's 3D printers that are out there now that do other tasks that are actually able to 3D print a better version of itself.
Then you would have a concrete printer, and that wouldn't work very well. It would be quite static. So no, but you know, the way we're looking at this is that we're probably going away from just letting it print, because this is basically a structure. So for instance, that EU tender we won was for a Belgian customer, and he wanted it to be able to lift in material to the building site also. So we are just applying a hook, and then we're using it as a crane and actually a supply system of windows and doors, et cetera, to the building site. So I think what will happen over time is that the printer, in brackets, will gain more and more functions, like it'll be able to paint, or it'll be able to brush, or it'll be able to put tiles down, or whatever. And I think that is necessary in order to address the other 65%, which has not been addressed yet. But this is, of course, a future technology, but again, showing, you know, what will happen when money is pouring in, and money is pouring into the industry now.
I have a final question for
Sure.
you, and it's your career, your curriculum vitae has been marked by pivoting between conglomerates, startups, and now this. I'd say you have an awful lot of ideas on your mind of what you'd like to do next. You might. What's your next plan?
No, my next plan is definitely within 3D construction printing, and the next version of the printer that we have plans for, which is going to be finished in 3 years from now, there are 25 new things that we want the printer to do. So no, you know, it's like I'm telling my people, you know, we can keep on developing this technology to be better and better and better and better the next 10 years. It's similar to what happened to the mobile phones, similar to what happened to laptops, etc. You know, you reached a commercial level, but development kept on going.
Well, look, just on behalf of the room, thank you very much for joining us here today. I think it was a really interesting and enlightening presentation. So thank you very, very much.